In this lesson, we're going to go into adding and subtracting fractions and then end with estimation of rational numbers, which is estimation of fractions. When we teach adding and subtracting fractions in 4th grade, and this is something I've already shown you in Lead Forward, in 4th grade, we give the students a common denominator. And I still highly recommend that you use a lot of manipulatives to show the students that when they have a common denominator, they're adding pieces that are the same size. And so, for example, I'm going to flip over here to an online tool. So I really like these fraction bars. And if you can order these for your class and have trays where they can get these pieces out and look at them, in 4th grade, we're going to be giving them problems where they already have a common denominator. And that's going to help them when they have these manipulatives see that they're adding pieces that are the same size, which will also be the same color because these are all color-coded. And so when they work with these, they'll recognize I'm adding fractions, but all of my pieces are the same size in 4th grade. When we get them into 5th grade, that's when we start giving them problems where they don't have a common denominator. And the goal is that they've worked with the manipulatives enough at this point that they recognize that their pieces are not the same size pieces. For example, a half and a third are not the same size piece, and that's ultimately why I cannot add them together. If I'm going to add fractions together, it has to be the whole split into equal size pieces in order for the pieces to be the same size and for me to be able to add them together. Now, if I was doing this in a class, I would hand out these fraction bars and I would have them pull out a half and a third and recognize that these pieces are not the same size pieces. And then what you do is you ask them, okay, we have to make the half and the third the same size pieces. So when they pull these pieces out, or they can even have them left in the tray, you could have them say, okay guys, we need to make these pieces the same size. And so we would start maybe with the fourth. Does the fourth evenly fit into the half? And what they can do is they can pull the fourth out and put it into the half and say, okay, that does work. And sorry, I mean, it's going to be a little bit, they'll be able to pull them out and see on this computer version. It's a little bit harder to see, but that's a pretty good job. They can say, okay, well, 2/4 fits into the half, so I can turn the half into fourths. But when I go to try the thirds, they're going to recognize that the fourth doesn't evenly fit into the third. And so that cannot be a common denominator because the pieces don't evenly fit into both of the fractions that you're trying to add. So then they could go to the fifth, and you could say, okay, well, can you evenly put fifths into your half? And so we'll drop in fifths, and they can get their pieces out and line them up. And I'm already overlapping a half, so I see that fifths don't evenly fit into the half. So then I go to sixths. And I say, okay, well, can I evenly put sixths into my half? So I pull this up, and we'll kind of try to line this up as good as possible. And that works. I can put 3 of my sixths into my half. 3/6 is equivalent to 1/2. Well, let's see if I can put 6 into my third. And that works out as well. 2/6 evenly, if I can get these lined up correctly, evenly fit into my third. And they will be able to do this if they have those pieces that they can pull out and move. They can see that a sixth is the piece, the largest piece, that will evenly fit into my half and into my third. And that's the common denominator, because what we did is we made the pieces the same size. And that's ultimately what getting a common denominator does. It takes your whole and it makes your pieces the same size piece. So if we're going to model that on your exam, what I want you to do in order to model this for me, and guys, the question that I put on your test like this, where it says model using fraction bars, you're going to do it this exact same way. So this is going to be on your test. And the way that I want you to model this is, we'll just do this by a drawing with fraction bars. So we'll say, okay, here is one whole. and I think I got this too big, but let me actually move this up and make this a little bit smaller so I can fit everything I need to. So okay, here we have one whole. So this is one whole. And then here I'm going to have the same size whole, and that's the key. I'm going to have my whole split into halves. Then below that, I'm going to have my whole, and I'm going to have it split into thirds. And guys, I apologize. It is so hard to write on this computer screen. So yours is going to look better than mine, and I apologize for that. And then below that, we're going to do one more line where we can just see all of these equivalencies. So it's pretty easy to get your pieces the correct size if you've drawn your lines even somewhat the size that they should be. So this is how I want you to model this, okay? On your test, because we can't pull those pieces over like we can on that computer software, so I want you to just tell me, because I can line up and see here, I can see that 3/6 and 1/2 are the same size. So we're modeling that by showing these fraction bars. 1/2 is equivalent to 3/6, not by the traditional way of getting a common denominator, but by comparing the size of these pieces and seeing that 3/6 slides easily into 1/2. Then let's switch colors. I can see here that 2/6 evenly fit into the third, so 1/3 is equal to 2/6. So when I add a half and a third, that's really adding 3/6 and 2/6. And now I have that common denominator, basically just showing that the pieces are the same size and getting that my answer is 5/6. And you'll notice here we never got the common denominator by the traditional way of multiplying this side by what it needs and multiplying the other side by what it needs. We made the pieces the same size pieces by deciding what is the first size piece that evenly fits up into the half, into the third, and it is the 6th. And that's exactly how I want you to model it on your test. I don't want you to show getting the common denominator by the traditional way, because when you're in 5th grade, when you're introducing the concept of a common denominator, this needs to be the first approach to show your students that you're really making your pieces the same size. And what we're actually finding is the least common multiple, the smallest common multiple that goes into both of them, and that's what the common denominator always is. Now, after you model getting a common denominator by making the pieces the same size piece for a while, then you will move into the way of getting a common denominator without having the manipulatives. So your first step is to find the least common multiple of both denominators, and then you rewrite the fractions, making both denominators that least common denominator. Once the denominators are the same, that's when you're going to add or subtract the numerators, which is step 3. And then on every problem we ever work, if anything ever needs to be simplified or reduced, that will be your final step. So I have some rules here also, just for making sure that you remember how to work with problems if we have different signs. So if the signs are the same, obviously we add and keep the sign. If the signs are different, meaning one of your fractions is positive and one of your fractions is negative, on different signs we end up subtracting and keeping the sign of the larger. And on subtraction, you can continue that process of adding the opposite, but you should realize, by this point most definitely, that a negative and subtraction mean the same thing. So following these steps, let's go into number 1, and this would be after we modeled getting the same size pieces for a while, because if we go back to our manipulatives, a lot of manipulatives are not going to have the 9th on them. So when you first start introducing fractions, you're going to do a lot of modeling showing making the pieces the same size with the fractions that you have in your manipulatives, and then you're going to go into fractions that you can no longer model with manipulatives, but they still need to very much understand that we're really making the fractions the same size pieces. So when I add the 6th and the 9th, sixth is a whole split into 6 equal-sized pieces. A ninth is a whole split into 9 equally sized pieces. So it should be very obvious to our students the reason we cannot add these is because these pieces are not the same size. So what we have to do is we have to find the least common multiple, which is going to be the smallest common multiple where I can make both of these fractions the same size pieces. And I've done this for a very long time, and I will tell you this is the absolute best way that I have ever found to do this. So I always have them underline circles, put a square around the largest denominator. And then we go up to the side and we write 4 multiples of that larger denominator. So 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36. And then I'll do ... because there could be times where we need to write more of those multiples, but we always start by making a list of 4 of them. Then we go to the other denominator, which is 6, and we say, can 6 be multiplied by a number to get 9? And it cannot. 6 cannot be multiplied by a whole number to get 9, so we know 9 is not the common denominator. Can 6 be multiplied by a number to get 18? Yes, it can. And so this is going to be the least common multiple, and I don't need the rest of your list. So just to repeat those steps, you're going to always identify your larger denominator and write 4 multiples of your larger denominator. Then you go to your other denominator and see which one of those multiples that denominator goes into. 6 does not go into 9, but it does go into 18, so that is the smallest common multiple. So what I'm going to do is I'm going to now rewrite both of my fractions with the denominator of 18. 9 gets to be multiplied by 2, so that means I have to multiply the top by 2 as well, because that keeps the fraction equivalent when you multiply the top and the bottom by the same thing. 6 is multiplied by 3, but I have to multiply top and bottom by that because that's what keeps it an equivalent fraction, because you're basically multiplying by 1. Now I rewrite those fractions. 3 times 1 is 3 over 18, plus 4 times 2 is 8 over 18. And now I have made those pieces the same size pieces. They're both 18ths. And remember that 18 is the size of the piece. So when I add, I have 3 of those and 8 of those. I have 11 of those 18th size pieces. And you will have students that want to add the 18s, but that's where you have to really reiterate to them that this is modeling the size of the piece. We have 3 of those pieces, we have 8 of those pieces, so we have 11 of those 18th size pieces. On the second problem, I'm going to be subtracting, but I still need my pieces to be the same size. So like I said, let's identify the largest denominator, and we're going to come over here and write 4 multiples of that. 15 times 1, 15 times 2, 15 times 3, 15 times 4. And my common denominator, we could need to write more multiples, but my common denominator is going to be one of those multiples in that list. Then you go to the smaller denominator and see what is the first one in that list that smaller denominator goes into. So can we multiply 5 by a number to get 15? And yes, we can. So we immediately found that common denominator and we don't need the rest of that list. Now 15 is already one of the denominators, so I will leave the 7 over 15 alone. The 5 to make it 15 needs to be multiplied by 3. So I multiply that by that top and bottom, and this becomes 6 fifteenths minus 7 fifteenths. And now I have a common denominator, meaning I've made these pieces the same size pieces. I have 6 of them, subtracting 7 of them, giving me an answer of negative 1/15. Now in this lesson, we're also going to work with improper fractions, changing them to mixed numbers. And I want to show you where that shows up in the TEKS. So we do not have students do a ton in second grade with fractions as far as being near as in-depth as in third, fourth, fifth, sixth. But I want you to recognize that in second grade, we use concrete models to count fractions beyond one whole, which means beyond one whole means this could be written as a mixed number when we go beyond one whole. We don't work a lot with those as far as the computation of them, but that's when the concept is first introduced. For example, 17 over 4, it makes 4 to make a whole. If you have 17 of these pieces, you have several wholes here. And so we could model this for them even in a drawing. So, you know, we have a whole split into 4 pieces, another 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 whole split into 4 pieces, etc. We have 17 of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 of those fourths, wholes split into fourths. So when we look at that, that's the same as 4 wholes and 1/4. That can be written the same way. These two fractions are equal to each other. They're exactly the same. One is written as an improper fraction. The other is written as a mixed number. So we're not going to draw models out every time. So how do we do that without drawing out the model? Well, we have to consider that the fraction line is division. This is dividing. We have 17 pieces divided into fourths, which means it takes 4 to make a whole. It's a whole split into 4 equal sized pieces. And so if I take 17 divided into fourths, 4 goes into 17 4 times, giving me 16 with 1 left over. That tells me I get 4 wholes out of that and then 1/4 left over. And what is the opposite of dividing? It's multiplying. If we were to go backwards to check that, we could say here 4 times 4 gives me the 16, going completely backwards of what we just did. 16 plus the remainder, the extra one on top, gets me back to that 17 over 4. Now on number 4, we have 96 pieces. Yes, they are negative, and it takes 7 pieces to make a whole. It's a whole split into 7 equal sized pieces. And so if I want to write that as a mixed number to see how many wholes I have, I take 96 of these pieces with it taking 7 to make a whole. 7 goes into 9 one time to get 7. Subtract, we get 2. We bring down the 6. 9 goes into, or excuse me, 7 goes into 26 3 times to get 21. And we subtract, we get 5. If the original fraction is negative, then obviously the mixed number would be negative. So we get 13 wholes, and then we have 5 pieces left over, but they're still the same size pieces. They're sevenths. And if we were to check that, the opposite of what we just did, dividing, is to multiply. So if I go back and check it, and I say, okay, what is 13 times 7? If I'm going to check that, just you have to keep in mind, and this is what really confuses a lot of people, you just divided to make that happen. So the opposite of dividing is to multiply. So we'll go 13 times 7 gets me to the 91. And then remember, we had these 5 pieces down here left over. That's why we add those 5 pieces back, getting me back to the 96. So let's go backwards. And now I'm going to give you the mixed number, and you're going to go back into the improper fraction. So here it takes 3 pieces. Every piece is split into thirds. 3 pieces in every whole. So you're going to multiply here. I have 8 wholes split into thirds. So when we multiply there, we get 24 plus the 2 on top gives me 26 thirds. You're going to multiply and then add. Multiply and then add. So 8 times 3, or 3 times 8 is 24, plus the 2 on top gives you 26. Now, if we were going backwards from that, it's 26 divided by 3. Well, 3 goes into 26 8 times to give you 24. When we subtract, we get 2. So that's 8 wholes with 2 pieces left over that are thirds. It's really easy to go back and forth between the two. All right, last one for this video. We're going to multiply our fifths, a whole split into 5 equal sized pieces, times 3 of them. So that's going to be 15 plus the 3 other pieces on top gives me negative 18 fifths. If the original fraction is negative, then the other version of that would obviously be negative. And if you wanted to check it, 18 split into fifths, that's going to go in 3 times to give you 15 with the remainder of 3, which means it's negative 3 and 3 fifths. Those fractions are equivalent.